Hello, so we'll be presenting about our data warehousing project. So we'll look into both the data warehouse designer's perspective and also the business analyst perspective. So firstly, the data set that our group has selected is the Brazilian e-commerce public data set by OList. So OList is the largest online department store in Brazil, and it connects the small businesses to major e-commerce channels. To understand the overall information of OList, we have explored some of the information of the business. So for the business model, the products of the sellers are listed on the OList store, where the customers can buy directly. And Olis also has the logistics partners to ship their products after the sellers fulfill their orders. After delivery, the customers will receive a satisfaction survey via email where they can provide feedback about their purchase experience. And there are a total of 8 entities right here. So there are customers, geolocation, order items, order payments, order reviews, orders and products, and also sellers. So firstly, let's look into the data warehouse designer's perspective. The first step that we have done is to clean and prepare the data. So overall, we drop the noun values for the IDs and the zip code prefix, and also cast types of the data into string and double, depending on the data. And we try to make all the data constant. So we change the data types of the specific columns into lowercase and uppercase, and also trim them to remove spaces. And also for some specific columns, we also have special techniques to deal with them. For example, like zip code prefix, we filled 0 in the beginning to make it 5 characters. For the timestamp, we parse it as date time and also change the format to be later separated into date and time in the data warehousing. And for the other numerical values, we drop null and negative values and also cast them to float or integer, depending on their proper format. And the orders and geolocation, we check the date time logic in a correct sequence for the orders, and also for the geolocation, we try to find the average latitude and longitude of the same zip code prefix. So this is our database design of the given data from the Kaggle. So this is the database containing all the entities as mentioned earlier, and also the relationships between each of them. For the design of the data warehouse, we utilize the 4-step design. So the first step, or step 0, is to get requirements. So we want to find the sales by product category and month, and also the top selling products. So the next step, we define the business process as the product sales activity, which is a transactional fact table. So second step, we define the grade to be each product customer bought from each seller. And the next step is to list out the DIMs to be used with the fact tables. So the primary ones are the product, customer, seller, sale indicator, date, and time. And we have applied some of the techniques as well. So the first technique is SCD2, which we apply to both product and customer by separating them into current and all in order to store both the historical data and also the current data. And the second technique that we used is to make the outrigger DIM, which is the geolocation DIM, and we connect this to the customer and the seller. And the last technique is we use the junk DIM, which is the sale indicator DIM, to combine all the indicators together into one DIM. And the next step is to identify the measures for this fact table. So this fact table will contain the price, the freight value, and also the total amount, which is the sum of the price and freight value. For the next fact table, we want to find the order fulfillment performance table. So that's why the business process defined is to be the each order lifecycle, which is an accumulating snapshot fact table. The second step, we define the grade to be each order of each customer from each seller. And the third step is to identify the factors or the DIMs. So it's similar to the last one, which is there are products, customer, sellers, sale indicator, date, and time, and also an additional one, which is geolocation. So we apply the same techniques. So the first technique is SCD2 to product and customer, the outrigger, geolocation, and also the junk DIM, sale indicator DIM. And the fourth step is to identify the measures because this is an accumulating snapshot fact. So it's like step by step. So we want to find the lag between these steps as follows. So after doing the 4-step design, we draw the diagram of both the fact tables with all the other DIMs related to them. So this is the result of the data warehouse.
And next is our system architecture. We are using Amazon AWS services, and we have designed it to be 3 layers using 2 services of Amazon. And the first one is our data lake, which will be using S3 buckets. This will be used to store our cleaned CSV file. And our second layer is the staging database. We will be using RDS for that, and we will configure it to be MySQL. And lastly, we have the data warehouse layer, and that is also using RDS and configured to be MySQL. We have the staging database so that it is more efficient to load to data warehouse, as we are dealing with several thousands of row, even up to 100,000 of row. So loading directly from the S3 cleaned CSV files to RDS data warehouse might be computationally expensive. Um, Having staging database may allow us to use SQL queries and store procedures. And next, we would have some configurations to do before we can actually begin with our processes. So we just need to set up our database for the staging database and data warehouse on RDS. And we have to create all necessary tables on both databases. And also, we would need to populate some tables on data warehouse first, for example, the time and the date dimension. And lastly, we need to create all necessary store procedures. And then this is the high-level flow of our ETL process. So first, we need to clean the data, and this is to clean the raw CSV files. We can do this locally, and then secondly, we just need to upload those into the S3 bucket manually. And then thirdly, we just need to trigger the ETL workflow. In the ETL workflow, what it will do is that first, it will load data from the cleaned CSV files on S3 to the staging database on RDS. And then secondly, after it finished loading to the staging database, it will load from the staging database to the data warehouse on RDS. And all of these jobs will be automated as we are using Amazon Glue to trigger. And in the next part, we will show you our ETL demo. And this is our ETL demo. So as we mentioned earlier that you would need to clean the data locally. So we will show you the script to do that. And this is an example of that. All we need to do is just run the script, and it will create a cleaned CSV file with the raw CSV file we had on our local machine. And once we get a clean CSV file, we just need to upload that to our S3 buckets. I have populated them before, so these are an example. And then afterwards, we can begin with our ETL on the Amazon service now. So before we can actually begin with any loading, we would need to first make sure that our crawler had once crawled through these data sources already. And these data sources include the S3 cleaned CSV files and the RDS, both for the staging database and the data warehouse. And what this crawler do is that it will extract the tables and the columns within each tables. For example, here, it can extract even for the CSV files, and all the columns will be showed up here so that it can be referenced in other jobs later. And after we finish crawling, then we are ready to load the data from the cleaned CSV file on S3 to the staging database on RDS. However, this is not the actual workflow. This is just an example for showing. This one is the actual workflow I ran. So you can see that the status is completed. I will explain this low-level flow for you because there are some conditions we would need to consider when loading also. So since some table are using foreign key referencing other table, so some specific orders have to be followed. And to briefly explain, first we will need to load to geolocation and a product table on RDS first, and then we can continue with loading to customer and seller tables. And then after the customer table, we can load to the order table. And after the order table, we can load to the payment table. And for the order item to be able to load, we would need the order, the seller, and the product table to be populated. And once we finish with loading to order item and order payments on staging database on RDS, that means that our staging database are ready and we can begin with our process of loading to our data warehouse. And I'm gonna pause you here a little bit because I want to show you that our glue can work. I have populated these tables on the database before, but I will delete them for now to show you that our glue work. And it will be taking quite a long time because we are dealing with several thousands of rows here. And you can see now that it's gone. So now I will show you the glue triggering. I will run this glue manually, just one job. And this one is for loading from the cleaned CSV file of order item to the staging database table. And then we will come back later because it will take quite a long time to load. So the process of loading to our data warehouse is a little bit different from loading to our database because the data warehouse, we will be using store procedure to load to them. And so what our glue job will be doing is that it will trigger those store procedures we have already created. And it will also have to follow some specific orders. And that is, first of all, we need to load the geolocation and the product dimension first. And then after the geolocation, we can load to customer and seller dimensions. And after we finish loading to customer, seller, and product dimensions, that means that our data warehouse we are ready to populate our fact table now. The other dimensions are already loaded before because they are using some fixed data, for example, the date and the time dimensions. And so if we finish loading to our fact table, that means that our ETL process is done. So I will show you a little bit of our script in loading to the database and our data warehouse. So this is an example of our script to load to order item. Mostly what it will do is just it will cast the type and it will check some condition for the foreign key constraints because these are linking to the table that need to be populated before. And we don't need to do any cleaning here because we already did that on our local machine. And this one is an example of the script to trigger the store procedure we have already created on our data warehouse to populate the dimension. All you do is just call those SPs. And here I will show you an example of that. So this is an example of tables dimensions I have already loaded on our data warehouse. And the store procedure we created would show up here, and we can just call them using the glue. And lastly, this is our example of our fact table. And this is the second fact table. And that is all for our fact table. Now let's go back to see if our glue finished the job. Seems like it has already finished, so we will check it here. And you can see that it's already been populated. Only using glue we triggered from the AWS service. And that is our ETL demo. So if you want to load any new data, our our SP will handle the SCD type of each dimensions. All you need to do is just clean the CSV files and upload it to S3 and trigger this workflow.